The following is a selected video from masterthecontent.com, where you will find an extensive video library of lectures for a variety of standardized admission tests. We offer over 600 hours of detailed video lectures for a multitude of standardized tests. Use our interactive in-lecture table of contents to find specific topics of interest. Work through numerous in-lecture examples to help you internalize concepts. To learn more, visit masterthecontent.com. Your career, our passion.
Example, Newton's third law, identifying action-reaction force pairs. Great. Janus carefully, so here we have Janus, right, carefully drags an oversized crate, right, across the floor by pulling on a rope. Identify the action-reaction forces. Wonderful. So we have three objects here that we need to discuss here. We have Janus, we have the rope, and we also have the crate. Wonderful. And knowing that there's contact here between Janus and the rope, and I'm just going to do it a little bit lower, but I'm referring to the contact here from the rope and the crate. So this point here is talking about the rope and the crate, and this point here is talking about Janus and the rope, right? Now, we'll start here with the force of the rope. The force of the rope on Janus. So that's how we'll depict it. The force of the rope on Janus is going to be equal and opposite in magnitude, in magnitude and opposite in direction to the force, right? To the force that Janus exerts on the rope. Wonderful. Now, secondly, we also are going to have a force that the crate exerts on the rope that is equal and opposite in direction to the force that the rope exerts. The force that the rope exerts on the crate. Okay, great. Now we have two action-reaction force pairs. We have one action-reaction force pair there, and we have another action-reaction force pair here. Now, action-reaction force pairs, they're always going to be equal and opposite, right, as we see here, right, but they're always acting on different objects, right? So that is why that let me just change my cursor. The force of Janus acting on the rope, right, is an action-reaction force pair with the force of the rope acting on Janus, and the force of the crate acting on the rope is an action-reaction force pair with the force of the rope acting on the crate. Now, let me ask you a quick question here. Is the force of Janus on the rope, right, and the force of the crate on the rope in action-reaction force pair? Think about that for a second. It's not, right? And now let's talk about why. We just said that action-reaction force pairs, they're equal and they're going to be acting on different objects, right? And we see here, well, let's begin with the force of Janus is going to be on the rope, and the force of the crate is going to also be on the rope. And because they're not acting on different objects, that is why they're not actually going to be action-reaction force pairs. Okay.